Are anti-gravity devices real? Historical claims examined. Are anti-gravity devices real? This question has sparked curiosity and debate for decades. Let's take a closer look at the historical claims surrounding this fascinating topic. Anti-gravity devices are meant to counteract or neutralize the force of gravity. Despite over a century of fascination and experimentation, no verified technology has been accepted by mainstream science. The earliest notable claims come from the 1920s. Thomas Townsend Brown discovered what he called the Biefeld-Brown effect. He experimented with high-voltage electrical devices known as gravitators or electrogravitics. Brown believed these devices could produce anti-gravity effects by manipulating strong electric fields. He observed that his asymmetric capacitor devices seemed to generate a force that moved them when powered, even during vacuum tests. Brown argued that this ruled out simple air-ion wind effects. He patented his ideas and promoted them as potential propulsion technologies for aircraft and spacecraft. However, rigorous experiments by the United States Air Force, National Aeronautics and Space Administration, and independent researchers found no thrust in vacuum conditions. They concluded that the observed effects were due to ion wind in air, not true anti-gravity. Nikola Tesla also proposed a space drive in 1928. His ideas were based on a dynamic theory of gravity involving ether whirls rather than curved spacetime. Tesla's concepts included electropulsation and anti-electromagnetic propulsion, but these remained theoretical and were never developed into working devices. In the 1990s, Chinese-American physicist Ning Li published theoretical papers suggesting that certain superconducting materials might produce a repulsive gravitational effect under specific conditions. Some experiments reported small anomalous weight fluctuations above spinning superconductors. However, these results were subtle, controversial, and never led to a practical anti-gravity device. More recent claims, such as those by Frederick Olzhoffen in the 1980s and 1990s, describe attempts to build anti-gravity craft based on peer-reviewed theoretical work. However, these experiments face difficult conditions, limited support, and equipment. The results have not been independently verified or widely accepted. Skeptics argue that the data shows no measurable effect on gravity. Overall, while many strange experiments have been conducted over the last century, none have conclusively demonstrated a device that can neutralize or reverse gravity. Most so-called anti-gravity effects have been explained by conventional physics, such as ion wind or electromagnetic forces. The history of anti-gravity research is filled with intriguing claims and experiments that challenge our understanding of physics but remains on the fringe. These stories often involve mysterious forces and unusual energy interactions. Despite the lack of confirmed breakthroughs, the quest for anti-gravity continues to inspire unconventional experiments and speculative theories.